completed the preparation of haloalkanes. Let us move on to the preparation of haloarenes. The meaning of haloarenes: the halogen derivative of benzene. Benzene is called as aromatic compound. The halogen derivative of benzene is called as haloarenes. Before we move on to the preparation, let me talk in brief about the molecule of benzene. Here we have represented the electronic structure of the molecule. Electronic structure of molecule means each atom of the molecule is shown its electrons of the outermost shell, not inner shells. Only electrons of the outermost shell in the form of the chemical bonds, sigma bonds, pi bonds, and a lone pair of electrons, that is a non-bonding electrons. That is each atom. The overall picture, the overall pictorial representation is called as electronic structure of the molecule. As you know, benzene is formed by 6 carbon atoms. 6 carbon atoms forming a cyclic chain with alternate double bonds. Cyclic chain with alternate double bonds. And the geometry of the molecule is planar. Geometrical shape is hexagonal. That is highly symmetric geometrical shapes. So all the vertices are similar, all the sides are similar. That is the symmetry about the molecule. Now look at that. The atoms present in the molecule usually not so, because carbon and hydrogen is only present. Look at the every vertex is similar. At the vertex now, the number of chemical bonds are 3. Each carbon is connected by 3 chemical bonds, 2 sigma bonds, 1 pi bond with the adjacent carbon atoms. So each carbon atom is satisfied with 3 valency. The remaining valency must have satisfied with the hydrogen, that is a CH. That is usually not shown, that is CH bond. Symbol C, H and CH bond not shown in the electronic structure is understood. Look at this vertex, that is CH is there, CH, 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 like this. Alternate double bond. There are 2 ways we can fashion it. This is also alternate, this is also alternate. Both are same. That means, so both are accepted, because that means these pi bonds actually keep moving. That is pi bond electrons. Pi bond electron is not localized, not stand still. The pi bond is keep moving like this. Because of movement you get this and this. So this is called as delocalization of pi bond electrons. And this kind of delocalization of pi bond electrons, the symbolic representation is circle, shows that pi bonds are always moving around. What is that? In the ring structure. That is a ring, hexagonal ring. So that is usually the brief, that is pictorial representation of benzene molecule. That is called resonance effect. It is a conjugated system. Conjugated means alternate double bond. That is called a conjugated system. Is keep moving. The pi bonds are not delocalizing all the time. So that delocalization of pi bond will reduce the reactivity of the pi bond, because benzene reactivity depends on the pi bond. Usually pi bond is reactive, but in case of benzene, that pi bond is not as reactive as the pi bond in linear molecule, because it is delocalizing. That is why any reagent to attack, usually the attack of benzene is the attack of pi bond. To attack pi bond, it requires a strong agent. What is that? Strong reacting agent. So with the attack of pi bond, that reagent will replace the hydrogen by other group. That is, by other group becomes what is a derivative of benzene. Any reagent which can able to attack the pi bond, it is only replacement of any one of the hydrogen atoms or two hydrogen atoms by other group. So it becomes a derivative of benzene. That is other compound in the form of other substituent. It is called as derivative benzene. It is also called aromatic hydrocarbons. That number of carbons we have discovered in numerous and also synthesized those compounds and numerous compounds. Enormous, a large variety of compounds we have discovered and also synthesized. That forms an entirely aromatic compound, a set of aromatic compounds, and the chemistry is called as chemistry of aromatics. It's a vast subject. Aroma. Those compounds have what is that? A odor. They are called aromatic odor, aromatic compounds. So with this brief introduction about the benzene, let us move on to the preparation of haloarenes. That is, it may be the preparation is a chloro derivative like this. That is from the benzene. Directly from the benzene. Using benzene, we can make the halogen is a chloro derivative, that is hydrogen. Here this hydrogen is replaced by Cl. That hydrogen is taken as HCl, that is removed as HCl. Here the hydrogen is removed and replaced by Br. It is bromo derivative, bromobenzene. It is called as chlorobenzene. It is called as iodobenzene. The hydrogen replaced by iodide. By the reagent, these are the reactants and the catalyst. Because this catalyst is a must, because as I told you, it is not as reactive as, it is less reactive. It requires strong, what is that? Lewis, as they are called Lewis acids. So here using chlorine with benzene, bromine with benzene, iodine with benzene, and these catalysts, Lewis acid. So the purpose of this Lewis acid, strongest, there are many Lewis acids we have. Can use any one of them for this reaction. Here ferric chloride, ferric bromide. Aluminum halide. This is actually anhydrous aluminum chloride. Anhydrous aluminum bromide. Ferrous chloride, ferrous bromide. Zinc chloride, boron trifluoride. All of them are Lewis acids. The purpose of this Lewis acid, they have generated electrophile because the reaction is electrophilic substitution. What is electrophilic substitution? Here it is hydrogen is replaced by Cl as plus. Electrophilic means plus electron deficient, carries plus charge, which can attack, because plus charge electron deficient can attack the electron rich, that is a double bond. That is why electrophile usually attack the benzene. These will generate electrophile and attack the benzene, form the corresponding compounds. Among these compounds, make one what is that observation here. HCl is here, HBr is here, HI. Among these, HI is a strong reducing agent. What is meant by strong reducing agent means that H it can donate easily, and again it is not, it act on this, reduces and produces the same what is the initial compound. So it can reverse, because HI forming can reverse the reaction because of strong reducing property. To avoid this, or to avoid the reverse of this reaction, we need to mix the reactants with any one of them. It is a strong oxidizing agent. They are as HNO3, HI4. What is HNO3? Nitric acid. HI4 is a periodic acid, very strong acids. Strong oxidizing. They are strong oxidizing agent, is a strong reducing agent. So oxidizing agent react with reducing agent. Reducing agent react with oxidizing agent, produces the corresponding to water and everything like this. And this of course is NO2 because of NO3 presence. So So it will, what is that, nullify the chemical activity of this before being acted. It is removed as this and this. This cannot act on this. So this will remain. So in the production of this iodo derivative, we need to mix with this compound just to avoid the reverse reaction. But here it is not case. It is not that case. HCl and HP are comparatively less reducing agent. This is a strong reducing agent. So this will not make a reverse reaction. So forward reaction is pronounced here in this case. So this is what derivative of allo derivative of benzene. This is known as chloro derivative. It is known as bromo derivative. It is known as hydro derivative. This is the reactions. Actual mechanism, we need to explain the mechanism of this reaction, electrophilic substitution. In brief, I will go through the mechanism of electrophilic substitution of any halogen, maybe chlorine, bromine, or iodine. There are similar mechanisms. Let me take the chlorination of benzene mechanism. What is the first step? I told you it is always electrophile can attack. Only electrophile means electron deficient can attack pi bond. Pi bond is electron rich. So first requires generation of electrophile. It is a strong Lewis acid. Electron pair acceptor. Since this compound, inorganic compound, aluminum chloride, strong electron pair acceptor. So this will accept the electron pair. What is that? That is bonding electron pair in form of Cl minus. So accept the pair of electron in form of Cl minus becomes what is that? It can break the chemical bond. Unsymmetric bond breaking of chemical bond leads to this. This Cl plus is generated, electrophile is generated, electron deficient, one electron deficient. That electrophile can attack the benzene, any one of the pi bond in the benzene like this. If this attack this pi bond, that means chlorine forming a chemical bond with this chemical carbon like this. So this bond breaks and forms a sigma bond with this Cl. So with this breaking, positive charge is moved on to this carbon. So this positive charge just move on to this with this attack. It is called as carbocation at this position. So when this forming carbocation, this carbocation is delocalizes in the benzene because of resonance effect. Delocalizes means the same thing electron, what is that? Changes the electron configuration. Here plus next stage, this bond, what is that? Pi bond, it can form between these two carbon. Change like this. If that is the possibility, this positive charge will move on to this carbon. That is this carbon. And again, this bond is keep localizing now. This chemical bond, pi bond, in between this carbon can move on to between these two carbon like this. Then the positive charge will move on to this carbon. That is carbocation. That is carbocation is generated at this position, this position, this position. But it cannot be generated at this position, these two positions. Only at these positions, carbocation that is generated. And finally, what is that? Because of the carbocation with this or resonance, it is called resonance structure, shown like this. Resonance structure. And this carbon now we need to what is that number? We need to number the carbon because substitution taking place at this. This carbon is named as numbered as 1. This carbon is numbered as 2, 3. This side 1, 2, 3 because these carbon are similar. So this is generated now when we rotate 90 degrees, it is the same molecular structure. This carbon is same, this carbon is different. So number the carbon as 1, 2, 3, 4 or 1, 2, 3, 4. These two are similar carbon. These two are similar carbon. This 1 and 4 like this. With respect to the substitution like this. So plus is generated at second carbon, fourth carbon and this one. This is called ortho position. This and this are called next to that carbon. Ortho position, it is called as para position. This is called as meta position. This or this is called meta position. So we have para and ortho, not at meta. Carbocation is generated. So now finally now with this presence of this and the carbocation, what is that? The carbocation and this plus and this will enhance, there is another step of reaction here. It breaks the chemical bond, remove as H plus, where remove as H plus, and this H plus is reacting with this forming FeCl3 and HCl. So the presence of this and carbocation will finally, what is that? The chlorine attacking the carbon, this chemical bond, what is that? CH bond breaks and remove this electron becomes pi bond. Now this sigma bond becomes pi bond like this, and it is removed as H plus because of this tendency of reaction forming this. This is a product, byproduct, this is a product, this is regenerated, hence it is called as catalyst, ferric chloride. You can use any one of them, either this or this or this like this. So that is what the mechanism. So all these mechanisms are similar, only if you can take chlorine, bromine or iodine. You can use any one of the catalysts like this. That is what the mechanism of halogenation of benzene. Next preparation is preparation of chloro-derivative of the compound like this. Look at the compound. Benzene is only benzene. Now benzene has already as a substituent CH3. So this compound is known as toluene. That is methyl group is already substituted, is hydrogen of this carbon is removed by CH3 group, is methyl group. It is called as toluene. You can convert this hydrocarbon. You can convert this hydrocarbon into halogen. What is that? Halogen derivative like chlorine like this. The reaction similar, mechanism is similar to this. Now this generates what is that? Cl plus like this. So Cl plus at which position now? Because the CH3, look at this property of this chemical bond, the CH3 group. So the presence of substituent, already a substituent group plays an important role. Which place? Either to ortho or para. The other substituent to be, that is an attack, that is a forming chemical bond, that is substituent as that. So here that is a kind, what is that? It is plus I effect. The CH3 is plus I effect. Inductive effect means plus inductive effect. Electron pushing group. So this CH3 through this C, electrons, the sigma electron bonds are pushing closely towards this benzene. That is benzene ring. So now whether the electrons are pushing into this benzene or electrons are withdrawing from the benzene, but will create this charge, whether negative charge or positive charge, only at this carbon, not at this carbon. At ortho and para. So that is a partial electron base. What is that? Partial electron charge is pushing. That is partial negative charge in the form of sigma bond pushing into benzene. So that is delocalization is there, but becomes what is that? Partially negative charge. That is partially positive charge. This is partially negative positive charge because of inductive effect, plus inductive effect. This is minus. Now because of the minus here, both are same. This is this. So minus will attract plus. So electrophile is plus. So now you can easily attack this position or this is same. This position and this position. Therefore, in this compound, this electrophile can attack this position as well as this position. In some molecules, it will attack this position. In some other molecules, it attacks this position, forming what is called orthochloro. It is ortho derivative, orthochlorotoluene. It is para-chlorotoluene. Of course, this is a major compound, this is a minor compound. This is because of the presence of a substituent group already present in the benzene. Will have effect on this like this. In some cases, the substituent take place at meta, not at chloro, that is ortho and para. It depends on just a brief that is knowledge about this. If a group like this, in general S, if a group like this group is electron donating group. This group is electron withdrawing group. That is electron withdrawing means it will push the electron, that is a pair of electrons into here, pair of electrons into it. But here not pair of electrons, it is pushing sigma electrons. So this is called as mesomeric effect. Here mesomeric effect means what? Is a conjugated system, whether linear or cyclic. Conjugated system means alternate double bonds and single bond and lone pair of electrons. Here alternate lone pair, single bond, double bond, single bond, double bond. Then we put double bond or lone pair like this, alternate positions. So that is the case. What is that? The lone pair and the double bonds are what is that? Undergo delocalization. They keep moving. Lone pair of electrons forming chemical bond at different positions. So it is called mesomeric effect or resonance effect. Resonance effect. So this resonance effect we see both in case of electron donating group and electron withdrawing group. This is electron donating group. The lone pair of electrons of the group will participate pushing these electrons into the benzene ring, forming double bond. So in this point, this bond breaks, and here it becomes plus, and these electrons now pushing now becomes minus, electron rich. This is carbon anion formation here. So this carbon anion undergo is a resonance effect. That is changes the resonance structures like this. This is just like that. Here it will come like this. That is resonating. What is that? It delocalizes. Negative ion is delocalizing the benzene like this. So again now at ortho, para, ortho positions only you see negative effect. The presence of electron donating group will create negative charge at ortho and para. If electron, that is electron rich, that positions are electron rich, usually the electrophile is plus. So plus electrophile. Electrophilic substitution easily attack at ortho and para. It will favor, that is activates. Already what is that is that these presence of this will activate these positions very much for further substitution of what is that electrophile. Like this. Presence of this electron donating group will activate ortho and para for further, will activate further. What is more activation to have what is electrophilic, easy electrophilic substitution at ortho and para. That is called ortho para director. Ortho para director, directing only ortho and para positions. What about the electron withdrawing group? That is electron donating group like this. If OH is, that is a phenol, that is connected to O and hydrogen. Carbon is bonding to O with two lone pair of electrons. This will take now, this will take plate. It can donate these lone pair of electrons with this like this. And what? Tatomeric, that is called mesomeric effect like this. This also nitrogen, NH2, amino group present in this. This lone pair of electrons, what is that, can donate into this benzene ring undergo this kind of resonance effect. Even chlorine, even though it is electron puller, it is electron withdrawing, but presence of lone pair will donate into electron, that is benzene ring, undergo this kind of mesomeric effect. This is called positive mesomeric effect. Electron pushing, electron donating into it. Positive effect. So called positive mesomeric effect. So groups like this in benzene, that is OH group, NH2 group, Cl group or Br group like this, will activate, that is O and P, for electrophilic substitution. Electrophilic substitution will be easy for further substitution. That is. But what about electron withdrawing group? That is called minus L. That is electron withdrawing, electron pulling towards it. That is why. That is these electron by bond electrons is what is that removed and pushing towards, that is withdrawing. It is withdrawing these pi electrons towards itself, forming pi bond. It is pi bond here, this pi bond cancel, it becomes negative. It is taking electrons, both electrons here too, negative. So result positive here. That is called, it becomes carbocation here, carboanion. So this carbocation is positive charge delocalizes with resonance effect like this. Is that ortho and para only like this. So as a result of this, we see that at ortho and para we have positive charge. So if already positive charge, what is that? Electrophile cannot. Electrophile is positive. Positive repulsion cannot attract. So it cannot attack. Electrophile cannot attack this position and this position. But we see the other option is only this point, meta, either this or this. At this point, no charge is generated, positive charge. So electrophile can attack this meta position like this. So it is meta director. It deactivates O and P positions, but activate the meta positions like this. Here. So this compound, that is, this is electron withdrawing group like this. NO2, the structure of NO2, here the carbon is bonding with nitrogen with these two bonds, oxygen. Among these electron, there is a large electronegativity difference between oxygen and nitrogen, that is pulling this electron towards this. And then this will pull the electron towards this. So this will move on to this, and these pi bonds will move on to carbon pi bond. So electron puller, very strong electron puller, nitro group. But here nitrogen is like this, not like this, only in this case like, because of this difference, this bond. And this carbonyl group, there is other group, it may be R, something other group. Carbonyl group like this, carbon with oxygen. Again a strong, what is that? A large electronegativity difference between oxygen and carbon. Oxygen and carbon make this, what is the electron puller, or which an electron pull from this benzene. So as an electron withdrawing group. So this electron withdrawing group will make this positive charge. That is positive charge. So positive charge cannot attack the positive. Therefore, it deactivates but activate the meta group. So only left position is meta position. So it is a meta director. These two compounds, this number of groups are like with this. So example like one, this is a meta director. Nitro is a meta director. Carbonyl is a meta director. That hydroxyl is a, what is it, ortho para director. Amine is ortho para NH2 amino group, and Cl is a meta para director, that is ortho para director. So this is just to brief about what is further substitution into the benzene, that is makes which position will take, decide. It depends on what group is present. Is it electron donating group or electron withdrawing group? It is a brief discussion about it, because it requires knowledge about what is the correct derivative of the benzene we get for further substitution. Next is all this from the preparation of haloarenes. Haloarenes from the benzene. Like this. And next, you can prepare the derivatives of all the chlorobenzene, bromobenzene, iodobenzene, and fluorobenzene from the compound known as benzene diazonium chloride. Most important compound in organic chemistry. Benzene diazonium chloride. From this compound, not from directly benzene, from this compound we can make easily all these compounds. What is the compound known as? How do you prepare? This benzene diazonium chloride is a salt, of course. It is prepared by a chemical reaction like this. Look at the chemical reaction. It is from the aniline, this is NH2. Benzene with NH2 like this. It is nitrous acid, HNO2. It is HCl. These are the reactants we need at ice cold temperature, 0 degree. In the liquid, it is water, ice water. This chemical reaction takes place. That is, what kind of rice? This O and nitrogen. This OH and H is removed as H2O. That is, one H2O, another H2O removed, and forming what is that? N with what is that? These two are removed and connection. These two are removed, this connection like this. Benzene diazonium chloride. But this bond, look at this chemical bond, is highly ionic bond. What is that? It dissociates. What is that? Dissociates in the form of ionic state. So it becomes electrons completely onto chlorine minus and electron deficient here because 4 chemical bonds plus. This is positive center, positive center. This is negative center. This is salt, benzene diazoyl chloride. Salt of positive charge, salt of negative charge. This is the most important compound. So this nitrous oxide is usually unstable. So whenever we need, we go for preparation as and when we require. It is prepared using the mixture of the compounds like this. That is dilute hydrochloric acid, sodium nitrite, salt is available. So mixing these in water and forming what is NaCl and nitrous acid. So for this HCl is HCl and mix all this thing into water, ice cold water, and mix with aniline and shake well, we get this compound, benzene diazoyl chloride. There is a preparation of benzene diazoyl chloride from this reaction. This is the most important compound in the organic chemistry. Now, mechanism we have. So let me talk about the mechanism of this in the next class. So using this compound, what halogen, how the halogen derivatives are prepared. We are using different reagents. This is a common one. Benzene diazonium chloride salt. By different reagents, that is this reagent and this reagent, reagents are different. We get the different derivatives. For the preparation of fluoride derivative, we use copper chloride. That is cuprous chloride and HCl. Temperature, heating between this temperature, these two temperature. So this Cl replace these two, that is KCl, and removed as HCl, and this removed as N2, that is nitrogen. So this group is removed as N2 and HCl. This HCl will replace this chloro derivative. For the preparation of bromide derivative, we can use this compound, that is similar compound, cuprous bromide HBr. For Cl, HCl like this, Br, Br, Br. So it will replace what is that, this group by Br and eliminate as N2 and HCl. For the preparation of iodide, here using this Ki with the heating with Ki solution. By heating with Ki solution, this is eliminated and a substitution by I removed as N2 and KCl. This Cl is removed as KCl. And the final one, look at that, for the preparation of fluoro derivative, the only important reaction. Using this, what is that, HB4 heated. This compound is heated with this HB4. This HB4 is called as fluoroboric acid. Fluoroboric acid, very important and very strong acid. Very strong acid. Strongest acid, there is of course strongest acid like this. So this will have effect on this. It will remove this as this and this and this. This is now BF3 and as substitution by fluorine. This fluorine is fluoroderivative. This acid is very important because very strong acid. It is usually this strong acid is to dissolve the scale form. The scale formation in what is that, oil wells. The scale formation usually find no oil wells. So it will block or clog the oil wells. It is actually eliminated those scales by putting this acid into the oil wells. It clears the blocks and easily you can pump out the oils. That is why this very strong acid, that is called as fluoroboric acid, effect on this produces this compound. So we prepare all the derivatives, that is fluoro derivatives, bromo derivative, halo derivative, iodo derivative and fluoro derivative using benzene diazonium chloride. Most important compound. This is the preparation of benzene diazonium chloride. So this you have completed. Let us move on to the next class. Thank you.